Welcome to Aryavat Center for Theoretical Physics. This is another video on this lecture series Statistical Mechanics, and in the last lecture I have explained second law of thermodynamics and Carnot cycle, and in this video I am going to explain what you call entropy. Take an example of any arbitrary quasi-static process or very slow changing process. The process is such a slow that it appears as static. So, and if we are taking any slow occurring process and we can reduce this process, this thermodynamic process, into a single what you call single heat reservoir with the help of many Carnot cycle. It means we can reduce any arbitrary quasi-static process into uh, single process with the help of small Carnot cycle, and or you can say that we can decompose that process into teeny parts or individual part, and with the help of Carnot cycle we can reduce into single heat reservoir. Now take an example of one small finite what you call individual process at temperature Tk, and this individual process, which is the part of this larger thermodynamics process, we are adding delta Q amount of heat to this individual process. Take this individual as kth element. So into this kth element, thermodynamic element, we are adding delta Q k amount of heat at temperature Tk, and also we are removing a delta Q naught k amount of heat from a single reservoir so that we can add into this, and that single reservoir has T naught temperature, and this we are doing with the help of Carnot cycle. It means the delta Qk divided by Tk is equal to delta naught k divided by T naught. It means this whole thing is equal. This is for the individual or kth thermodynamic element, and this is for this reservoir which we are removing some heat. Now in case of cyclic process we can sum up all the individual element. So summation all individual thermodynamic element delta Qk divided by Tk equal to summation of all what you call all the heat, individual heat we are removing from this reservoir. So delta naught k divided by T naught, and here delta naught k sum of all the small amount of heat which we are removing is Q naught. So delta Q0 k from k to nth element is equal to Q naught. So Q naught by T naught. So summation sign delta Qk divided by Tk is equal to Q naught by T naught, and we know that this process is also cyclic process. It means there will be no change in the heat for the reservoir. It means Q naught is 0. It means this whole term is 0. So delta Qk divided by Tk is equal to 0, and we are taking a limit where z is approaching infinity. So this whole cyclic process delta Q divided by T is 0, and this function, this is the function of the state, and this delta Q divided by T is called entropy. So entropy is heat added or change in the heat divided by T, or you can say that change in or you can say that for the cyclic process change in entropy is 0. or you can say that heat added or added or removed divided by T is 0, and this whole term delta Q by T is called entropy. Now pay attention to this ratio delta Qk divided by Tk. This is for the individual or a finite number of or a small individual process, and this is for the single heat reservoir where delta Q naught K amount of heat is removed from this reservoir, and this ratio of this is exactly equal to ratio of this one. And for the cyclic process, this is 0, so this will also become 0, and this division is also called entropy. So this is the definition of entropy.